When you want to run your first microplate respirometry experiment in MicroResp, you must first calibrate the oxygen sensor spots mounted on the floor of each well to get accurate oxygen readings. Calibrating the oxygen sensors can be done in the Settings tab in the Experiment menu, but before entering, a microplate reader must be powered on and connected to your PC via USB. Note that we are running in demo mode, so the microplate data you see here is virtual data. In the Settings menu, under the Calibration section, you can choose between two types of calibrations: factory or batch calibration and a manual 2-point calibration. The predefined or factory batch calibration uses a batch file containing the factory calibration data from back when the sensor spots were manufactured. The specific batch file number is located on the black plastic bag that the glass plate arrived in, and the file can be chosen from this list. However, optical oxygen sensors can bleach over time, especially when exposed to UV light, resulting in a signal drift, which will give inaccurate oxygen readings. This is why we highly recommend performing your own manual calibrations for experimental trials instead of using factory calibration data that should only be used for preliminary trials. Another reason is that optical oxygen sensors are very temperature sensitive, so it's important to keep the temperature of the sample and glass plate constant at ±0.5 degrees Celsius and to calibrate the sensors at a temperature within ±1.5 degrees Celsius of the experimental temperature. And as you can see from the file names in the list, these batch calibration files were calibrated at just two different temperatures, 10 and 25 degrees Celsius. The manual or 2-point calibration option calibrates the oxygen sensor spots at two different air saturation levels, 0% and 100%. The calibration procedure is a little different depending on if you calibrate in water versus in air. If you are calibrating in water, start by keeping the microplate reader, the glass plate, and calibration water within ±1.5 degrees of your experimental temperature for around 60 minutes. This can be done using our optional flow-through water bath or by keeping the entire microplate setup in an incubator or in a temperature-controlled room. Then type in the experimental temperature in the temperature field over here. Now fill the wells with the 100% air-saturated water sample. This mixed air-equilibrated water sample can be achieved by purging atmospheric air into the water sample, for example, using an air pump and air stone. Once the oxygen readings are stable, click the Read and Use phase and temperature values. The microplate reader will now read each oxygen sensor spot and transfer the data to MicroResp, and the calibration data can be seen using the eye icon here under the phase high for each well. Then fill the wells with the 0% air-saturated water sample. This oxygen-free water sample can be achieved by purging nitrogen gas into the sample water or by dissolving 10 grams of sodium sulfide in 500 milliliters of distilled water. Once the oxygen readings are stable, click this Read button again to read the 0 oxygen values. Again, the eye icon verifies the data now under phased low. The phase values should normally be around 54 for the low calibration and around 46 for the high calibration. And you're done! Up here, you can now save the calibration data and load them back in for later use. But MicroResp will save these data internally until you change them or reset the software settings. Remember that you must perform a calibration for each of your connected readers separately and also for each of your glass microplates, as the sensor spots in each plate are different. If you're calibrating in air, simply follow the same steps as when calibrating in water. But instead of a 0% and 100% water sample, use just nitrogen gas for the 0% calibration and leave the sensor spots exposed to the ambient air for the 100% calibration. Remember to maintain the temperature of especially the nitrogen gas also within plus minus 1.5 degrees of your experimental temperature. The optional flow-through water bath can be useful since you can pass gas through the closed water bath to easily expose all of the sensor spots. In the calibration section, we find the normalization factor. Normalization will set all air saturation values to 100% by multiplying with a factor, so that each oxygen curve has the same starting point. If the oxygen sensor calibration is good, normalizing will not change the percent air saturation values much, typically less than plus minus 10% if performed at 100% air saturation. Normalization should be performed after setting both calibration points and when there's 100% air saturation, water or air in the wells. We generally recommend performing a new calibration if the experimental temperature differs more than plus minus 1.5 degrees of the current calibration temperature, if the air saturation readings start to vary by more than plus minus 10%, or after performing a sterilization using ethanol according to the quick guide. And that's it on how to calibrate your oxygen sensors in MicroResp. If you have any questions about calibrating in MicroResp or about other aspects of the software, you are welcome to contact us on our website.